Okay, so we left off yesterday. We were talking about some linear function stuff, right? And we were looking at slope, and we reminded ourselves that the slopes of parallel lines are equal, and the slopes of perpendicular lines are always opposite reciprocals. Yes, ma'am. Oh yeah. Who was gone yesterday? Okay, yeah, let me pass this out. So a bunch of you missed this part. Okay, raise your hand again if you're gone. Ooh, 3 in this row. Okay, there you go. Oh, you were here yesterday? Yep, okay. Who else was gone? Kylie was gone. Ashton was gone. Oops. Okay. All right, there we go. There we go. There we go. Okay. All right. So we were just doing a little review yesterday, and there's a video available. If you weren't here, you might need to catch just a little bit of the first part of the video. But a lot of this, it goes pretty fast. This is just a review of linear equation stuff. So maybe I'll just take a step back here so we can just take a brief review for people that were gone. We introduced standard form of linear equations. Okay, standard form is written in this way. Standard form is written as ax plus by equals c. We write it with capital A, B, and C always. Okay? A, B, and C are just numbers, and there are some criteria that we have to follow when we write it this way. A, B, and C are integers. That's an important rule we always follow. The greatest common factor of A, B, and C needs to be 1. So if I could divide both sides of this equation by something to make these smaller integers, I would. Okay? And then the other thing that's a rule that we sometimes follow and sometimes, depending on the textbook, this may or may not even be a rule. I'm not so hung up on this one. I don't think this is a very big deal. But in this particular, this note sheet, they want you to write A as a positive number. Okay? It has to be greater than or equal to 1. I'm not sure that we're going to really worry about that too much. I can't remember on the assignments. I don't even think that's necessary. But when we get to the assignments, I'll look in there and tell you for sure. That one's not such a big deal. We did a couple examples where we had to convert some linear equations into standard form. Let's take a look maybe at just this guy right here. What would I have to do to convert that to standard form? What's wrong with it right now? Fractions. So what would I have to do? You got to clear the fractions for standard form, right? So what would I distribute through both sides? 12, yeah. Okay, so if we multiplied both sides through by 12, 12 times 3/4, what's that going to be? The 12 over 4 reduces to a 3, right? So what do I end up with then? 9, there you go. So I get a 9x. 12 over 3 reduces to a 4, right? So I multiply that by negative 1y, and I get minus 4y. And then 12 times 1 is 12. And we're done. We're good, right? That's all we had to do. Sometimes we have to rearrange terms. Like in this case, if I just push the 7x over there, I get 7x plus 7y equals 7. Is that enough? What's wrong with that? Okay, good. I could divide both sides by 7, couldn't I, to make those coefficients smaller, right? So if I divided the whole thing through by 7, then I end up with x plus y equals 1. That's my answer in standard form, okay? All right. We moved on and we talked about slope-intercept form, the one with which you're probably most familiar. Y equals mx plus b. Remember, m's the slope, b is the y-intercept. We looked at what it means to be a positive, negative, 0, or undefined slope. Positive is going to be an increasing function. From left to right, the ant's walking uphill. Negative, from left to right, the ant walks downhill. 0 is a horizontal line, is the slope of a horizontal line. The undefined slope is the slope of a vertical line. That's easy to remember because that's not even a function, right? It violates the vertical line test, okay? And then we did some examples where we put functions into slope-intercept form, which only amounts to solving for y and simplifying. Anytime you isolate the y in a linear equation and simplify, you're going to end up in slope-intercept form every time, right, if you solve for y. And then graphing these is a piece of cake. All you're going to do when you graph any line is you're going to essentially create 2 points and connect and extend, right? You start with a point. So, for example, in this case right here, we started with the y-intercept of +1. We made a slope triangle from our slope. The slope tells us to rise by -4 and run by 1 to get a second point. Once I get 2 points, I connect and extend, and we're good. Okay? Which led us to this stuff. Okay? So now we're determining whether lines are parallel, perpendicular, or neither, given the fact that parallel lines have equal slopes, perpendicular lines have opposite reciprocal slopes. So let's focus on these two lines, the red line and the blue line, trying to determine if they are, how they're related, parallel, perpendicular, or neither. So what's the critical parameter here that we're interested in finding out for these two lines? Slope. All we care about is slope. We don't care about anything else. The slopes will tell us if these are parallel, perpendicular, or neither. So the easiest way we talked about, you guys came up with a good plan here. This is a simple way to do it. You told me that that means we just want to isolate the y so we can put this into slope-intercept form and see what the slope is by just inspecting the coefficient of x, right? If I isolate y, whatever's being multiplied by x, that's going to be the slope of the line, correct? Okay? So what about this first one? I'm going to get the y by itself. What are the steps to get the y by itself? Okay, so I'm going to subtract 9x first. Right? And then what? So that gets rid of that first term. Then what do I do to get the y by itself? Divide by -6, right? So I'm going to subtract the 9x to this side. I'm going to divide by -6. And then what's left after that? Who cares? We don't care, right? We just care about the slope. So all we need to know is what's the coefficient of x? What's the number going to be that's multiplied by x? Well, -9 over -6 reduces to what? 9 over 6, which becomes, say it again, negative? Positive, there we go. Negative divided by negative is positive. So we get 3/2 x plus, doesn't matter, right? The slope here, this tells us that the red slope is 3/2, okay? And I'd argue that you guys can do that in your head probably, right? You could look at that and say, okay, if I subtract the 9x and divide by -6, 3/2, right? You can just about look at that and do it in your head, okay? What about over here? I want to isolate the y. What do I do? I want to isolate the y in the blue equation. What's the only thing I have to do? Divide by -3, right? And we end up with 2x divided by -3 plus, not interested, right? We don't care about the second part. All I have to do is simplify that fraction. 2 divided by -3 is -2/3, right? X plus, it doesn't matter. And then we end up with our blue slope being -2/3. So what's the relationship then? If the red line has a slope of 3/2, blue line -2/3, how are they related? Perpendicular, right? Because they're opposite reciprocals. There you go. Okay, good? All right. Give me 1 to 5. Okay. So X and Y intercepts. There's a pretty cool way to do this. X and Y intercept. So the X-intercept is where any function, in this case the line, crosses the x-axis, of course. The y-intercept is where the line crosses the y-axis, okay? So we want to identify the x and y-intercept of the graph shown on the right. Well, let's look at the x-intercept. Okay, what are the coordinates of the x-intercept? What are the coordinates of the x-intercept? Negative 3, 0, okay. What are the coordinates of the y-intercept? Okay, 0, 4, right? Okay. No, there's a big difference. Okay. So I drew special attention to the zeros, right? Notice that the x-coordinate of the y-intercept is 0 and the y-coordinate of the x-intercept is 0. That's important. This allows us to do some interesting stuff mathematically to find these things. Okay. If we want to... Oh, okay, so x-intercepts, there's a little other terminology. We'll just add, we'll talk more about this later. But x-intercepts, so here's an x-intercept. They could also be referred to as roots, zeros, or solutions. Okay? And we'll talk about each of those in a little more detail later on. But for now, they're just interchangeable. Okay? So to find the x-intercept of an equation, then, what might my strategy be for doing that? What am I going to do? Can you come up with a strategy for finding the x-intercept of any equation? What do you think? Yes? Yeah, right? If I want to find, well, you know, what am I going to put to 0 for the x-intercept? Here's an x-intercept. What could I do? If I want to find the x-intercept of any function, what could I do? Say it again. Set y to 0. Yeah, right? Because don't all the x-intercepts, if they are occurring on the x-axis, every point on the x-axis has a y-coordinate of 0, right? So if we want to find out what the x-coordinate is, we just ask the math gods in the form of an equation, what happens when y is equal to 0? By setting y equal to 0. Set y equal to 0 and solve for x. Conversely, if I want to find the y-intercept, every point on the y-axis has an x-coordinate of 0, and so I'd ask the math gods for the y-intercept by setting x equal to 0 and solving that equation. Okay? And then if we have those 2 points, what's convenient about that is all it takes is 2 points to graph a line. So I could use those 2 points to connect and extend to create my line. Have you done stuff like this before? This is a little new? Okay. New little trick. Okay, so let's try one. Find the x and y intercepts of the equation y equals negative 2x plus 5. I'm going to make that a little bigger. So how am I going to find the x-intercept? What's my strategy for finding the x-intercept? Set y to 0. Okay, good. So if y is 0, this is a pretty cool little trick. It's nothing like so amazing, but it works really well. This is called the heaviside cover-up method. We use this in calculus sometimes. And all you do with this cover-up trick is that if I'm setting y equal to 0, then doesn't that term over here become 0? So I can just cover it up and solve for x in the equation. What are the 2 steps to get x by itself? Subtract 5 and divide by, so what would I end up with? So I'd get negative 5 over negative 2, right? What is that? It'd be positive, right? 5 halves? Everybody agree? Okay. So now I can do that in my head. I think it's easier personally because the negatives can mess you up. I would push the 2x over here and divide by 2 and get 5 over 2 personally. But, you know, your choice. So we cover up the y term and solve for x, and we get 5 halves. If I want to find the y-intercept, I'm setting x equal to 0. So I'm just going to cover up the x term, right? Because if x is 0, wouldn't you agree that negative 2 times 0 is 0? Right? If x is 0, that whole term becomes 0. So let's cover it up and solve. Well, it's already solved. What's y equal to? 5. Okay, and now that I've got these 2 points, I could just plot those 2 points and connect and extend, and I got my line. Make sense? Okay? All right, so let's try a couple of these. About this top one, let's find the intercepts real quickly. And this is one, would we have to do it on this one? No, we could just graph this one by using slope-intercept, right? That might even be easier. But sometimes when we have equations like this, right, that one's going to be easier to do with our cover-up tricks. I don't actually even have to solve for y. See what I'm saying? Okay. Let's practice with this first one, though. So if I want to find the x-intercept, I'm setting y equal to 0. What's that give me if I solve for y? Or solve for x, sorry, 1/5? Yeah, so that's hard to graph. I'm going to do this, I'm going to put these in fifths. So there's 1, 2, 3, 4, 5. So there's 1, 1, 2, 3, 4, 5. There's negative 1. There's positive 1. There's negative 1, right? So my x-intercept is 1/5. So that's right there. Gosh, keep messing up. 1/5, and we set y equal to 0. My y-intercept, if I set the x term equal to 0, what's y equal to? Well, negative 1, right? Oh my goodness. So 0, negative 1, that's supposed to be a negative 1 there. And now all I have to do is just connect and extend, and I got it. Okay? Let's scoot up and do, when are we out of here? 2:45, okay. Let's try a little more difficult one. Let's try something like, how about this guy up here? Okay. Okay, so for the x-intercept, I'm setting y equal to 0, so we'll cover up that term and solve. It's not very convenient, but what's that give us? If I solve for x, 24/5, right? That's what somebody said? Okay. So y is 0, x is positive 24/5 if I divide negative 24 by negative 5. So that's, what is that just shy of 24/5? 5, right? That'd be, yeah, just shy of that. That'd be what, 4 4/5? So 4 4/5 over 1, 2, 3, 4, and I'm just going just right up close. Oh, why is it? It's thing is doing some weird stuff. Okay, there's my X-intercept. Y-intercept, going to set X equal to 0. Solve for Y, what do I get? 6, good. Okay, so if X is, Y is, oh, I did that backwards, didn't I? No, I'm good. I said X equal to 0. No, I'm good. Said X equal to 0. Confused myself. Set X equal to 0 and solve for Y, and we got positive 6. 1, 2, 3, 4, 5, 6. So there's that point. And then I can just connect and extend, and we got it. Okay? Give me 1 to 5. Good? Okay, what about number 6? Any suggestions on number 6? I'm going to be, these fractions are not quite as convenient to work with, are they? I don't have to do this, but does anybody have a way maybe to make number 6 a little bit easier to work with? Yeah, why don't we clear fractions, right? If we distribute a 12 through, what's that going to give us? If I distribute the 12 through, 12 times 3/4, that gives us our 9x minus 12 over 3 is 4, right? So I get a minus 4y when I multiply that by the top, equals negative 24. I might still end up with some fractions in my answer, but at least they're a little easier to calculate now. Okay, so let's figure this out then. Our X-intercept and our Y-intercept. So our X-intercept, if we set Y equal to 0, what do we get when I solve for X? What's that going to give me? If I solve for X there, X equals, okay, negative 24 over 9. Can I reduce that? What's that reduce to? 8 over 3. Okay. Negative 8/3. So as a mixed number, what would that be? 8/3. 2 2/3. Good. Okay. So negative 2 2/3. I'll just write it as negative 8/3. But when we graph it, we're negative 2 2/3. So right about there. How about my Y-intercept? So now I'm setting X equal to 0 for the Y-intercept. And what's that give me if I solve for Y? 6 again, right? Okay, 0, 6. So 0, 3, 4, 5, 6. And again, all we got to do from here is just connect and extend. And we're good. Okay? Questions? Make sense? Okay? All right. I'm going to give you just a few minutes here to decompress for the weekend. You can work on the assignment if you want to. We won't. This is kind of the next topic. We'll pick this up on Monday. You can, if you have any questions, why don't you go ahead and just use the time. I mean, fire up your Chromebooks real quick and see if you can get a couple answered. Maybe if you got any questions going into the weekend, you could ask me. I'll just be up here waiting for questions.